Hey, you people of algebra persuasions. We're going to tackle lesson 71, at least the first part, the easy part. And we're going to be using the law of sines. If you took geometry, you were thinking that law of sines was that was something that you did and you never want to do again. Well, guess what? It's back with a vengeance. But now you got a little different context because you watch the thing on superhero triangles like 9, 10, 17, or 7, 15, 20, where the perimeter and the areas are the same. You were introduced to Heron's law, or Hero's law, whichever way you want to say it, where they started with figuring out the area of a triangle when you didn't really know the height, that you could rewrite things in terms of knowing the area and knowing the base, and you could have the height. And you're like, well, how in the world do I get the area without having the height? Because that's what I need to get the area. And we had Heron's formula, which all you needed was the lengths of the sides. You came up with the thing called the semi-perimeter. Add the three sides together and divide by 2. And then do this fun little thing here under the parentheses. That was Heron's formula, which is in your book, and we'll talk about more. I did a proof for Heron's formula a few years back. It was involving the side condition. It starts like this, and it's got that exact same triangle there at the very beginning that I have up here on the board. And you use sines and cosines and some pretty interesting expanding and substituting. You use some tricks I learned from Leonard Euler. And I get down to the place where I almost have it done. And then I finish that sucker off. So that was quite the exercise, but it was fun. And then I gave it to Willem, and he cleaned up my work a little bit. But it goes to show that the geometry and the algebra were related to each other and were interactive with each other. So we're going to start law of sines here by connecting it to area formulas. The first steps that I had to do with this problem of going from algebra to geometry, to going from this thing to Heron's formula proving it, was needing the area of a triangle being 1/2 base times height. Now, it's really easy if you have a right angle in there because you can just orient it and you got a base and you got a height, you got the 2 legs. But not with this one. And I drew it kind of just, in general here so you don't think anything's a 90-degree angle. What I do have is, though, if I drop a 90 here, if I drop the perpendicular, a little 90-degree angle down there, I can put the dotted line in there for the height. And I've got the base. That's the whole length here to cross from angle B. So what I need to do is I need to write H in terms of the other business that I've got here. And how I do that, I go over here to angle A, and I see this little triangle right here. A, B to that perpendicular. There's my triangle. And I can define this H if I take the sine of this angle A. Sine of this angle A is going to be H over C. And then if I would like to just have it to equal H, I'm going to multiply both sides by C. That is, I get this. Okay? And then I can just plug that in for H to get 1/2 B times C times sine of A. And there's my area of any triangle given that I've got an angle and then the 2 legs that are its rays. That is, I've got 2 sides and their included angle. That is, it's the side angle side condition. Side angle side implies a couple of things. Number one, it implies if I know, well, I guess using Heron's formula I could figure out the third side, but It's enough for me to draw that picture. If all I was given were with the instructions of the lengths of two sides and their included angle, I just can put that angle there, whatever angle it is, and then I go, well, this side is, maybe it's 5, and this side maybe it's 10. That's enough for me to figure everything else, because this has to go to there, and then I got a couple of angles to figure out, and I got another side to figure out, but that's enough to draw the picture, and then to go from there to figure out the additional bits of information. So this is one of the formulas for the area of a triangle. It just depends on which vertex you label A, B, C, and then you got to label the sides that correspond to that. Side A is across from angle A, side B is across from angle B, and side C is across from angle C. That all has to be set up the correct way. And now we don't need that height. We're going to use sine values in order to do the work. Again, this is going to work with a side angle side condition. That's what's given to us. And now we can go ahead and solve the problem. The book shows two other equations, and that would just be if you were trying to do that problem from either angle B or from angle C, that you would have varieties of these things. So another one would be AB sine, it's a lot of sines, sine C, or I guess what's left, AC sine B. You can find the area of the triangle for many of the three sides given which one that you have, but all these three are equivalent to each other. So here's where it gets really interesting. If we take 1/2 BC sine A, we see that it's equal to 1/2 AB sine C, and that's equal to 1/2 AC sine B. We can move these parts around. You see everything's multiplied by 1/2, so we can get rid of that. We don't need that. But these must be equal to each other. And if we rearrange the parts, we get to what's known as the law of sines. Okay? It'll look like this. Well, there's a couple ways it'll look. Either it'll be the sine of A is to A as the sine of B is to B as the sine of angle C is to C. Okay, it can look like that, or you can just invert everything. A is to sine A, as B is to sine B, as C is to sine C. And you're only ever going to use two of these three parts. Okay? You only need one unknown. You need to know 3 bits of information, right? 2 sides and an angle. That's the side angle side. Or 2 angles and a side. Well, if you know 2 angles, you know 3 angles. Angle, angle implies angle, angle, angle. So we had a couple of conditions that we're allowed to use. And it just depends on if you want to solve for an angle or if you want to solve for a side, which might be the most convenient. Again, you're only going to use 2 of the 3 parts so that you have 4 pieces all together. 3 of them are known and 1 of them's unknown. And I tend to, if I'm looking for a side, I tend to use this version down here. If I'm looking for an angle, I use this angle, this version up here. Let's get to, I'll give you the cases that we can use today, and then in the next episode you'll see the difficult cases, the ambiguous cases, where you have to actually have the picture. But you can use the law of sines, with these 2 conditions. We will also use this or little side angle, but we've got to watch out when we get there. Today we're going to look at this stuff right here. 2 angles, 1 side. Okay? I'll give you a couple of pictures of that. I'll give you some fairly randomish type of triangle. This is not to scale, so don't be like, that's horrible drawing. I know. Okay? I know. Can't even connect the lines. So this is side B. This is side A, this is side C. And we're given that this is a 56-degree angle, and this is a 43-degree angle, and side A is 15. Now, of those equations that we use, what would be the best? This first one might say, let's solve for side B. Let's solve for side B first. Okay, well, if I want to solve for a side, I'm going to put it on the top and compare it to its angle. Now, the other thing is, I know this one, but I don't know that one. And I need to use another pair that I have both pieces of information. And this question, I have angle A and side A. So I'm going to put angle A and the sine of A here. Now I'm just going to plug the numbers in or move the pieces around. If I'm solving for side B, this one right here, I'm going to move sine B to the other side. It'll be sine of B times A divided by the sine of A will equal B. It's just basic moving the pieces around. Pause that, maybe you want to get that down, because now I'm just going to substitute in the sine of 43 degrees. Side A is 15. Sine A, 56 degrees. And then the calculator takes over from there. Make sure at this point that your calculator is set to degree mode, not to radian mode. Won't work with these problems when we got degrees to get you the right answers. When you get your answer, you should look at the picture and see if it makes sense. This is a smaller angle than that one. Your answer for B should be less than 15. Okay, so try that. Make sure that you get an answer less than 15. Does it jive with your picture? Once you get that answer, you can go after one of the other, well, I guess if you know two angles, you know the third angle by doing a little subtraction, and then you can go after side C in a very similar fashion. Okay, so you're given enough information if you're given 3 bits of information. 2 angles and a side actually gives you 4 bits of information. It gets you 3 angles and a side, but that's all you need in order to do these types of problems. I'll show you another triangle here where we could use this. Let's get kind of a tall, skinny one here, and we'll not tell you what this side is or this side is, but that must mean that that's angle A and that's C, and this is angle B up here. And then they're going to give you the 2 lower angles. This is going to be an 83 degree, and this is a 76. That doesn't sound right. Well, that must be a really, really small angle up there. So I guess that's okay, because it's still less than whatever, less than 180. Okay, and the little line segment here, side B or segment AC is 22. So this is side B. We have here angle, side, angle. That's our other condition that we can use. And again, we're given enough information here. If we're given 2 angles, we can figure out the third angle. And we can go and solve for either C or for A. If we'd like to solve for A, we're going to say A is to sine A, which is 83 degrees, as, what else we got? As B, which is 22, is to the sine of B, and B could have been calculated by going 180 minus 83, so it's 97, minus 76, so that's 7, 10, 17, 18, 19, 20, 21. 21. I think that's right. Let me double check on me. But anyway, I got 3 parts. I need to find the 4th part. Once I've got that, I could do the other one. I could find C using the same process. C is to the sine of C as B is to the sine of B. The rest of the information then can be derived from the information that is given. Okay? Well, there you go. You have to pick the right one, and then you have to pick kind of the right setup. And then your first thing is you got to decide, like, which thing do I go after first, okay? And again, if I'm trying to solve for a side, I'm probably going to pick a setup like this. If I'm looking for an angle, I'm probably going to use something like this. Let me just quickly say that if you do get a situation where you're setting it up like this and you want to solve for angle B, here's what you're going to have to do. We're going to have to move side B over to that side here to get B times sine of C over C. And then to get just the angle and not the sine of the angle, we're going to have to take the inverse sine of both sides. That is, take the inverse sine of sine, we'll get B. When we take the inverse sine over here, we'll get, do this to the whole thing in parentheses. Okay, so that's what that would turn into if we're solving for the angle, given we started right here, that this, solving for B, turns in to this. Just a little bit of algebraic, trigonometric manipulation, but there you go. So I would give you a few suggestions first. Number one, first thing you want to do is determine what case that you have. Is it angle, or is it angle, side, angle? So that you can orient yourselves and see what information you have and what information do you need to find. Okay, that's the first thing. Both this lesson and the next one, determine the case. Okay, hopefully it's not one of these. Those are a little bit trickier. Second, compare sides and angles using the law of sines. So you match up side A and side B and angle B, all that stuff. And then thirdly, solve for the unknown, either side or angle. And once you figured out the first one, you can go after the second one. Again, angle implies that you got 3 angles. The rest is just working out the details. Start somewhere and work from what you know to what you don't know.